Welcome to SolarEdge Night Mode, your after-hours happy hour for solar enthusiasts and solar professionals. My name is Chris.
My name's Cameron.
And we are so glad to have you here with us in our new studio.
Yes.
Yes.
So the new studio bugs continue to plague our existence, but we're working through them.
Absolutely,
and
yeah.
Today, we're going to talk about grounding and bonding, I think.
Yep, you're grounded. But first, before we do that, we had a question that came in on the preview video to this episode. And the question was, what happened to the live installation that we were going to do?
Oh, that's right. For those of you who didn't know, unfortunately, I had a medical emergency and was unable to record that day. So we had to abandon the cause because I was in a hospital. The good news is I am safe, I am happy, I am healthy. There is nothing ongoing with my health issues or concerns, so yeah. I think we're all good.
Yep. I am really glad to have you back with it. And very important question, what are you drinking today?
I went pretty basic today.
Yeah?
It's starting to get warmer outside. I wanted a little bit lighter beer. I was on my walk earlier today, and I decided, you know what? Instead of a dark beer, I'm going to go with a blonde ale. Yeah. And we had some Firestone Walker 805 sitting in the fridge, and I decided that sounds like a perfect, tasty beverage for a warm spring afternoon.
Oh, absolutely.
It's a well-known beer. I'm pretty sure you can get 805 just about anywhere.
Yeah.
Yeah.
It's a very, very good beer. I managed to walk down to my local brew pub and picked up, let's see if I can get this in camera, Dead of Night from Oak Park Brewing.
I like that label.
Yeah. Super nice. Very, very Poe-esque.
Nevermore.
Absolutely. And so this is a very nice nutty porter. It's very good.
Cheers.
Cheers.
So as a reminder, always drink responsibly.
Absolutely.
What are our wives doing today?
I believe they are going roller skating.
Oh, yeah?
Yeah.
Like a roller skate.
Yeah, like roller skating, like old school, like 70s, 80s, 90s, early 2000s now.
Yeah, where are they doing that at?
Well, there's actually a refurbished roller rink in town, so it's pretty exciting. It's a very state-of-the-art.
Oh, no. That was wheelie bad. I could do it too.
It's bad, but that's how I roll.
Thank you for bearing with us.
Okay. All right. At this point, we're just spinning our wheels, so let's move on.
People will stop watching us.
All right. We got a couple of cheers and jeers this week because you had a really exciting week last week, right?
Yeah. So I was in Salt Lake City, just outside of Salt Lake City called Farmington. And there was this fantastic installation that we took part of. We were on a TV show called Designing Spaces from the Lifetime Network. And in that show, we gifted and donated this beautiful mural to a family that had recently suffered a major loss. And we wanted to help ease the burden, emotional burden of that. So we donated this beautiful mural. And there was a local installer, ES, that donated solar installation. So we contributed the optimizers and the battery and the inverter. And now that family, the Fia family, has the capability of having a backup on their home, and hopefully, in coming months, they'll see how much their energy bill has reduced, and they'll be able to rest a little easier after experiencing a loss like theirs. But it was a fantastic project, and if you posted the picture at all, the mural turned out beautiful. It's got a picture of their son, and then the things that were meaningful to him. He was a tremendous athlete, probably could have gone to the next level, and so he loved playing football, and he has his tribal art tattoo that was on his casket. He wanted it as a tattoo, but he was still a little too young to get it, and so they had one designed for him, and that was incorporated into the mural, and he taught himself how to play the ukulele.
Oh, cool.
So he just talked to his dad quite a bit, and he figured out how to play the ukulele on his own, and then would just learn songs, and so that was a big part of him. And so really awesome Tongan culture, really cool project, really cool kid. And the inverter, the installer decided they didn't want to cover up any of the mural. So they used the back conduit entries on the inverter. So just no conduit anywhere in that space, and just made it look really cool.
Right on. That is super cool, and I love seeing that.
Yeah.
I, on the other hand, have something that is a little less fun.
Oh, a jeer,
Or
if you will.
a jeer, if you will. Saw something interesting when I was. We're here in the SolarEdge office. We are in the support office in Roseville,
Yeah.
and a lot of good folks and a lot of great stories. You know, occasionally you'll see an installer that will submit the same picture over and over again.
Yeah.
When they're trying to RMA an optimizer.
Yeah.
And usually that
Wait.
triggers.
It's pretty easy to RMA and optimize it.
Yeah. It's just,
you
you got to go up there anyway. Just measure the thing, take the picture. But, you know, that type of behavior is something that will frequently trigger an audit and possibly a freeze of your company's RMAs. And so it's generally not a good thing for you as an installer to do. This one went a step above.
Oh, no.
Now, see if you can tell me what's wrong with this image.
Oh no.
Oh, yeah.
What's wrong with those MC4s? What are those?
Oh, yeah. Look at how it's mounted.
Oh.
And then when you look at the multimeter, then it just like falls all apart.
This is AI.
Yes, this is absolutely AI. Somebody went into ChatGPT and said, I don't know, give me this. And ChatGPT, you know, did a fairly reasonable job if you don't know what you're looking at.
Look at the multimeter, 0.0.0.
Zero dot. The file that they submitted even had like the ChatGPT file name on it.
Are they measuring the date?
Yeah, so yeah, maybe don't do that if you are out there and you're installing equipment. Definitely not the best look for you or your company, and again, could be repercussions for that, like triggering an audit.
Woof.
And yeah, because they do notice, because that was submitted multiple times. So
this is evidence.
Shake of the finger, yeah.
Well, so the support staff, they do review those.
So this week we are talking You're Grounded. And the reason this came up was multiple reasons. Number one, I saw a great post on LinkedIn from an installer who was out on site dealing with a moisture-related isolation fault or ground fault that was happening every morning. And I looked at the picture and I saw that the shadows were like really, really long, and it was obviously everything was still like covered with dew. So the guy went out there in the early morning when the faults were actually happening to troubleshoot.
Yep.
Because I can't tell you how many times I've seen installers go out there to troubleshoot water-related isolation faults or moisture-related isolation faults, and they go out there at like 3 in the afternoon. There's nothing wrong with this thing.
Yeah.
And then it starts up the very next morning. So good on you, my dude. Way to go. The other reason is because we're working on a product for Meter in a Can, which is basically alternative options for installing the SolarEdge Nexus Islander.
That's right.
So that it can be installed into different appliances, and there is an instructional video that goes along with an app note that tells people how to do that. And there are some very important concepts in there that I talked with the field team. They said they're seeing mistakes happen on this on the regular,
Right.
And that is neutral ground bonding. So we're going to talk about that as well.
Okay. I think those are great topics of conversation. And then additionally, I think the SolarEdge Nexus inverter has kind of some key points about bonding, how the chassis is aluminum and it's listed, and so we don't have to bond it using a ground bushing. So I think there's a lot to talk about here.
Yeah.
That's fantastic. Okay.
And while we're talking about this, should state for the record that, you know, we're going to be talking about things on a very surface level. If you really want to do a deep dive, there's a lot of fantastic resources available.
Yeah.
But the number one rule is always going to be follow the direction of your code adoptions, your AHJ, your company's safety practices. Do what's right in your jurisdiction. We're just a couple of guys that are sitting here having a beverage and talking shop.
Yep.
Always follow your local rules. But if you do want to dive deeper,
You can go to there's a great channel called, I think it's Electricians U.
Yeah.
And they do a great job of explaining electrical theory, code requirements for circuits, and I think they even have like paid courses to help you get like some type of certification or something like that. And so yeah, check out their channel if you wanted to know more about grounding and bonding in AC systems.
It is a fantastic resource, and again, you can, if you are in a trade that it applies to, they've got programs where you can get CEs, which I think is just fantastic for just watching the equivalent of just fun YouTube videos. And they really do a deep dive, really explaining all of these concepts in depth where we're not going to go today, but that's again a great resource. My Colt forums, any of our application notes, and of course your NEC code book.
Yeah.
And your local AHJ.
Yeah.
Yeah. Great resources for all of those things.
Okay, so how do you want to get started?
Let's break it down by like some simple terminology.
Okay.
Let's break down the basic concepts, starting with a grounding electrode.
Okay, so what is a grounding electrode? So grounding electrode is a piece of metal or something that's conductive that is put into the earth, like the physical ground.
Yeah.
And when we use ground, and you can think interchangeable to earth, we're talking about earth.
Yeah.
So a grounding electrode can be a water pipe system, a UFR, a grounding rod, so a big 10-foot or 8-foot copper rod that's driven into the ground. It could be a metal plate. It could be structural steel. So a grounding electrode is a object that is intentionally buried in earth to provide a path of current to ground, to earth.
Okay, and then a couple different types of grounding conductors. We've got your ground electrode conductor.
Sure. So a grounding electrode conductor is a conductor that ties the grounding electrode to the system, whatever you're trying to protect. So it could be, when we say system, usually we're talking about like maybe a house, some circuits, but it could be like a utility transformer connection. They drive their own grounding electrode, and they have their own grounding electrode conductor. So system could be any electrical system.
Yeah. And those differ from equipment grounding conductors. How?
Yeah, so equipment grounding conductors are different in the sense that they are designed to protect equipment and have a fault path to the grounding electrode system. And so equipment grounding usually could be your metal box, like if you're looking at a motor or a pump or something like that, if there's metal components, that's got to be grounded, and you use a equipment grounding conductor to do that.
So that's like that green or yellow and green conductor that we see like bonded to every single piece of metal equipment that's carrying current.
Or bare copper, yeah.
Yeah. Okay, and that of course brings us to the definition of bonding, which is a very specific definition and has implications within the code.
So bonding is basically when you take two pieces of metal and electrically connect them. So you can bond your metal enclosure. You can have a bonding conductor that is a little wire that maybe has one piece of rail, like a solar system, one piece of rail to the next. That could be your bonding jumper or your bonding wire. But basically, it's just connecting two metallic things to one another electrically.
So in the case of like equipment bonding, we're like getting in there into the metal. That way we got a path of least resistance.
Yeah. And so the grounding conductor is really designed to shed current in a fault condition. So if there's an electrical short happening somewhere, it provides a path of low impedance for all of that current to get to earth to prevent electric shock hazards and fires and stuff like that.
Okay. And neutral ground bonding.
Oh, so a neutral is a ground-dead conductor. So a difference between a grounding conductor and a ground-dead conductor is a ground-dead conductor has a intentional bond to ground, to earth, and a grounding conductor is intended to carry that fault current to earth.
Okay, now I know that because we've got two different types of electricity, we've got AC ground faults and we've got DC ground faults, and they don't necessarily behave in the same way. And I know you are like an expert in DC grounding. You like know the history. It's just all right there.
Yeah. I've been around, Chris.
Can we start with RCD, or residual current detection, which is what the inverter does before it starts producing every time. It sends a little bit of current down one side of a circuit and sees what comes back down the other. And if there's any discrepancy in those two numbers, then it's like, okay, well, now I've got a potential issue. So you detect isolation faults before they happen.
Yeah.
Yeah. But so how did we get here?
So the reason we do this is because I'm going to say most inverters today are ungrounded, or they're called transformerless inverters. That's on the DC side. And the reason they're ungrounded is to save cost. The inverter becomes more efficient. But if we think about historically what inverters were when they first came to the US, we called them line frequency transformer-based inverters, or isolated inverters. And what happened is if you had a ground fault, or there was a unintentional connection between a current carrying conductor and a non-current carrying conductor, then the inverter would detect this and perform galvanic separation from the grid using an isolation transformer.
Yeah.
And the first inverters kind of in the US were transformers that were 60 hertz. So they had really big copper windings, and it was this big, expensive, heavy piece of equipment. So back 20 years ago when I started installing solar, it was the Sunny Boy inverter with it weighed 127 pounds-ish. I think it was like 60 something kilograms. And it was a big chunky inverter that took two people to lift. It was heavy. Then we realized that copper winding was expensive, and your negative conductor was grounded, and there was like this fuse that would blow if you had that fault. And so then the industry moved to high frequency isolation transformers. And all that did is, instead of performing galvanic isolation on the AC side, now it did it on the DC side. And we still performed that separation from the grid, adherent to UL 1741 and IEEE rules. And that is how inverters shut down when there was a fault. And again, it still had a little protective fuse. Then the industry is like, let's get rid of these transformers altogether. That's how they do it in Europe. They have ungrounded DC systems, and that's pretty much all inverters today in the US is ungrounded or transformerless because it's lower cost. So now we have an ungrounded negative and positive conductors. We still have to have a way to detect a fault. And SolarEdge does that through this residual current. So we send a high voltage, low current signal through the wires to force, if there's let's say there's a little nick in the wire, and there's a lot of moisture in the air, to your example in the beginning. There's a lot of moisture in the air that those electrons can climb through the moisture and be detected as a ground fault. When that moisture goes away, dries up, that air gap becomes bigger, and those electrons can't jump and close that circuit anymore. So what the residual current does is, or the RCD test, what that does is it forces a high voltage, so it forces those electrons, increases the pressure, forces the electrons to jump, and if they make contact with something that's not supposed to, then we can keep the inverter from producing and keep the system safe, reducing electric shock hazard and fire risks, right? And that's how we do it. So I think today, because everything's ungrounded, I think everyone performs this kind of residual current test. It's like running a megometer through your system.
Yeah. So in my experience, the most common sources of isolation faults or ground faults on the DC side, definitely going to be pinched wires for me. Wires that have been rubbing because they weren't properly managed, damaged panels, and I've got a great story about that one. And of course, possible equipment failures.
Yeah.
What are the most common that you've seen?
Yeah, I usually see like J boxes where maybe they used the wrong type of wire nut or didn't close it all the way, or just got a whole bunch of water in it and deteriorated over time, right? So J boxes, especially rooftop J boxes are the biggest ones where I see it, and pinched wires is like the number one. You accidentally put a panel on a wire, and then you crank it down, and it just pinches that wire, and then over time, expansion contraction causes that conductor to braid, and I've seen some horror shows. I've seen conductors just lying on comp shingle roofs and rubbing raw. Like, I've seen some pretty gnarly stuff out in my days.
I was helping out an installer buddy of mine, and he was having some trouble finding an isolation fault. And my first question to him was, have you opened up the inverter yet? And he opened up the inverter, opened up the DCD, and immediately just fish-bowled.
Oh,
like
no.
just water poured out of the thing. And it was because he had that side entrance to the DCD, and just water came in from the roof, because water will find a way eventually.
Yep.
And it just slowly filled up the DCD of the inverter.
That's one of the things that scares me about Nexus is like we allow side entries again, which is, again, awesome and easy, and I know why we did it. But I wanted to make sure we have two really big weep holes that allows that water to escape. And that was the flaw in that old, it was the old A series inverters that had that. And I remember there was a Noah Tuttle is our code and compliance officer now, and we were talking, and our revenue grade meter sat a little bit below everything else, and the DCD would fill up with water, and then that meter would stop working. And the meter was the reason people would go roll their truck to site to troubleshoot why the meter stopped working. The same thing, they'd open up the cover and just water would pour out. So he coined the phrase as the revenue grade meter is actually the early water detection system.
Okay, one more story. I had a buddy in the industry, and he was one of the early adopters of picking up maintenance contracts with solar installations where maybe the installer went out of business or filed for bankruptcy and disappeared. Basically just picking up all these orphaned system owners.
Yeah.
And he found this beautiful contract for a field mount or ground mount that was in this field, and on one side of the field was an elementary school. On the other side of the field was a series of baseball diamonds.
Oh, no.
So anytime you had a kid that was having a bad day with a rock, throw it out there, isolation fault. He'd go out to site to fix the isolation fault. Anytime there was a foul ball, hit a panel, broke it, isolation fault. And
with the glass, picking up the
he
moisture.
would go out there at least once a month to replace panels. I feel bad for that site owner because I don't know who did the initial field survey on that one.
Yeah, jeez.
Okay, so one of the questions that I get most often is, can support just run a test and see if they can figure out where the isolation fault is before I go out to site?
That's a great question. I get this question a lot too. And no, the short answer is no, we can't run it remotely. The largest reason is when you are detecting a ground fault, you need to isolate your strings because we're checking an impedance value, right? And if all of the strings are in, it's going to give us the wrong value.
Yeah.
So when you run your isolation test, you basically do it one string at a time. And so if you have 3 strings, you unland 2 of those strings and then run your ground fault detection, your isolation test, is I think what we call it in the menu. So you run your isolation test and it'll give you a value, and that'll tell you where the fault is if it's there. So that's how you do it. I mean, you made the Learning Labs video.
I did, but I always like to hear your take on things. It only works if there's only one string in the inverter, and there are very few installations out there that are one string anymore.
That's right.
So chances are probably not. There is a great application note out there that will show you how to do an installation or how to go through and test for isolation faults one string at a time. If you get like a 100%, I think it's like on DC negative. If it's 0%, it's DC positive. If you run into that situation where it's like saying it's like 0% or 100%, just get a jumper, throw it off the roof from your J-box, and then run it straight to the inverter to see if there's an issue within the home run. Yeah. Typically, it's like, a handyman was going in doing some work and a nail went through a conductor. Yeah. That I've seen happen more than once. Yeah. But yeah, great application note for that, and definitely worth reading.
Yeah, absolutely. And then, of course, if you had your megometer, you could do it, but same thing. Like you want to unconnect your optimizers from the string, test your home runs first, and then if that proved inconclusive, then check the circuit with the optimizers in it. And the application note, I think, tells you what voltage to set your megometer at. You don't want to pump 1500 volts through these optimizers. You're going to cause failures. So I can't remember if it's 1000 or 500, but I think it's 500. Check that application note.
Yeah. And I'll just go ahead and link that in the description when we're done with this. And again, big tip here, if you've got an isolation fault that's happening in the morning because of moisture, go there in the morning, like my dude on LinkedIn. Seriously. Don't go there in the afternoon trying to troubleshoot something that only happens within the morning. If you've got monitoring, what you can do is you can right-click on your inverter, and you can look at the errors that are happening, and you can see exactly when they are triggering, or you can ask support for a little bit of assistance if you can't figure that out.
Right.
But you can see that, like, oh yeah, from 6 o'clock in the morning through 7:30, I'm getting all these isolation faults, and then they suddenly go away.
Yeah.
That's usually moisture, and that's usually a J-box or somewhere in the system. Yeah.
All right, so let's talk about, so we're still talking about grounding and bonding, and you said you wanted to talk about backup systems.
Yes, backup systems really, really important to talk about because, I came up doing small wire, so I was doing comms wiring. I am not an expert in, AC installation, installing sub panels. I've got, my basic level of understanding and ability, but I came up doing small wire and then moved into DC.
Yeah.
A lot of guys, like their experience when they're working with AC is probably limited to installing a breaker, maybe putting in some CTs or doing a line side tap, not like actually going through and installing an entire like sub panel or backup panel, which has all kinds of different rules and regulations that go along with it. And that's typically where we're seeing the most installation mistakes.
Yeah.
So I thought it was definitely worth talking about like ground faults on the AC side, because it's pretty rare that you get an AC ground fault that will trigger a ground fault on your inverter.
Right.
And you could be hunting for something that's on the DC side that could be on the AC side. But as far as ground faults on the AC side, they behave a little bit differently.
Yeah.
And one of the myths that I always believed about AC ground faults was that as soon as there's a ground fault, all of that voltage or all of that current is going straight to ground. And that's not necessarily true. Typically what will happen is like, on your single phase grid, you've got, your 240 that's center tapped with your neutral, and that gives you 120 and 120 or 240 as you need it. And that comes into your home. And whenever you power a load, like a single phase load, it goes out on a hot, comes back on the neutral, and then that's how you complete the circuit back to the transformer.
So your neutral is your ground dead conductor.
Well, it is bonded inside the main service entrance.
It's ground dead.
So at your service entrance.
It's intentionally connected
It's intentionally grounded in one place. And so that's so that you can create that path of low resistance so that if there is a ground fault, let's say we have a conductor that fails for whatever reason and is touching the chassis of a piece of equipment.
Right.
Now that chassis that is bonded to ground has become electrified.
Yep.
And it's going to follow the path of least resistance, which is going to be your ground, all the way back to the main service entrance, go back to the neutral, complete the circuit, and then you're going to get, for a very brief amount of time, you're going to get a whole lot of amperage that goes through, and that's what's going to trip your breaker.
That's right.
So breaker trips, problem solved, very, very momentary problem where you've got a lot of current, but that is quickly resolved.
Right.
Now that's not to say that there's a non-zero amount of current that is going out on that ground rod. That absolutely does happen, but the circuit is created by going back to the neutral.
Right.
So we run into a lot of issues where installers are bonding neutral and ground in a number of different appliances, like say a sub panel or a disconnect.
Whoops.
Especially with like 2-pole disconnects, because the factory installed neutral lug typically has a little green screw in it. If you don't back it off and you've got your neutral going through it, you've
Right.
bonded neutral to ground there, and your sub panels by default are going to have that little green screw in there that is bonding neutral to ground.
It's interesting because I think any service entrance rated panel that you buy has that neutral ground bonding jumper installed, but any sub panel you buy that is not specifically a service entrance, I thought they included it as an option, like, hey, you may need this, but you're probably not, so they intentionally left it out. But so this becomes a problem as
Yeah.
we do more and more backup systems, especially if you're trying to use a meter collar that is not installed behind the billing meter. And so you're creating a backup panel and you're confused about what your neutral ground bonding, where it should happen.
Yeah,
And so
well,
the short answer is your neutral should only be bonded to ground in one place on the load side of the service entrance, and usually it is the first disconnecting means. So if you have a main breaker, that's where your neutral ground bonding occurs at the service entrance. In some older systems, you might see it happen at the meter socket, but usually it's at the first place of disconnecting. And I think it's chapter like 250, Article 250 in the NEC that defines grounding conductors, equipment grounding conductors, neutral conductors, and where to bond these things together.
Yeah, the big problem though is now that I've got multiple neutrals bonded to ground, now I've got multiple pathways
Yeah.
for that current, that high ampacity current, to make its way back and complete the circuit.
Right.
Which now, because you bonded neutral to ground in a sub panel, includes all of the different loads that are attached to that neutral bar.
That's right.
And that could potentially result in that breaker not tripping and you damaging those loads.
Yeah.
Or, worst case scenario, having pieces of equipment that are now electrified, or plumbing, or a shower, or any number of things. So
Right.
really, really important that you only bond neutral and ground in one place.
That's right.
Yeah.
So if what we historically saw with backup interface and like partial home backup systems was multi-wire branch circuits, and that being a big issue, where when you have a multi-wire branch circuit, usually what's done is a electrician will run three conductor Romex, so like 310 or 312 or 314, which is a black wire, a red wire, and a white wire, and a ground wire, right? And so they'll take the black wire and do maybe the lights of a kitchen, and then they'll do the red wire and do the receptacles of a kitchen, and that is called a multi-wire branch circuit. And they have the black wire and the red wire have to be on opposite phases of each other. So black wire phase A, red wire phase B, and then they share the neutral conductor. And so they would land like a 2-pole breaker, 20 amp breaker, 2-pole 15 amp breaker, because both of those switches, if they share that neutral, need to be disconnected at the same exact time. So you usually use a 2-pole breaker for that. And again, they have to be of opposite phases. And so we would see for electrical systems that maybe in a partial home backup that they would only pull maybe the light circuit and not the receptacles, or they would do the receptacles and not the lights. And so now you have part of a multi-wire branch circuit in a backup panel and part of a multi-wire branch circuit in a main panel that is not connected by anything except for the neutral conductors, and it's a dangerous scenario. So we, SolarEdge, we wrote a white paper, again, we can throw it in the link or the description or whatever, about how to detect a multi-wire branch circuit and why they all need to be in the same panel together. So you either back them both up or not at all. And I think that problem is going to go away now that we have the meter collar, because creating a partial home backup system, not likely the case for Nexus because of its high LRA. The meter collar means you don't have to make a backup panel.
Yeah.
So there's a lot of reasons that the meter collar will make that problem go away. But it is an interesting interesting phenomena that happens for those that did not pay attention.
As much as I love the old SolarEdge product, being able to back up more than 20 amps is such a wonderful, wonderful thing.
Yeah.
Especially considering, and I know I'm talking about our product, but I love our product. Especially considering, like with Nexus, you can go through and you can set your on-grid power.
Yeah.
And then when you're disconnected from your grid, you can set an off-grid power.
That's right.
So that you could potentially, even if you couldn't like install a 10K inverter because of whatever rules and regs you have with your utility, you could have a 7.6 that could do like 12.4 in backup. Is it 12.4 or 12.5 in backup?
With the existing product, it's 12.5 kilowatts in backup. With Nexus, it's 14.5 kilowatts in backup.
Yeah.
Yeah.
So lots and lots of power if you've got the batteries to run it and the sun to run it.
Yeah, yeah.
Which is why we allow so much oversizing.
Exactly.
Yeah. Yeah, so when you're out there, if you are not fully versed in AC installation and you're doing backup, no matter what manufacturer it is these days, it's going to be a more sophisticated system. The best thing that you can do is go through and make sure you re-up all of your knowledge on the AC side, because I can tell you just honestly, like most of our installers have the DC side down, flat out. That's like, you know, you can go out there, slap glass, get that inverter on the wall, you're good to go. But when it comes to a lot of AC installation, that's where we see trouble happening. So I'm also glad that we're, you know, providing a solution that has like a meter collar where you don't necessarily have to do all of that work as well, which is very nice.
Right, exactly. Yeah. Well, and it's, you know, systems are as easier as they are getting, they're also in some ways getting more complicated. So again, through the history of the industry, we went from negatively grounded conductors, and in some cases there was positively grounded conductors if you were using sun power panels. And then we have evolved into like transformerless and ungrounded systems that are easier to install and more cost effective. But now things are getting more complicated because now we're doing backup systems more regularly, and brushing up on your neutral ground bonding is important. And I'll be the first to tell you that, man, when I first installed a meter collar is in our, we call it meter in a can, which is basically you buy a standard service entrance with a meter socket, and you plug in the meter collar, and then you put a jumper cover over the top of it. You don't need a billing meter, and then you populate your service entrance with breakers. And the beautiful thing about that is basically you're making your own backup interface with off-the-shelf parts. But when I first did mine, because I swapped out my buoy, my backup interface, and I put this panel in, I was like, oh man, the neutral and ground are bonded here. There's no way for me to unbond them. So I had to go buy a specialty neutral bar that has like these little razors that keep the neutral off of the metallic enclosure, so I can keep my neutral and ground isolated.
The good news is I have early access to the app note.
Yeah.
And I can tell you that that app note tells you specifically what products to buy and the exact part numbers.
Yeah.
Because I will tell you, look out for this. If you're ordering on like your big box hardware store type websites, their websites will try to be very, very helpful. If you put in a part number and they don't have it, they may recommend another part that is very, very similar to it or could work for you, but is not the same part. So we did this a couple of times where went on a website, searched for X part, and then when we got it delivered, it was a different part.
Yep.
So make sure that you are checking the exact part number in those situations.
Absolutely.
Questions came in from Mauve. Are neutrals always hot? Neutrals in a circuit, like if it's a 120 circuit, yes, by itself, it was just a 120 circuit. It's got to have a way to come back, and that is the neutral.
Yep.
Now, there are special situations in cases where you've got two identical loads on different phases, where you're still going to have your neutrals be hot coming back to the main service entrance, but going from the main service entrance back to your utility, because you've got those phases in balance, there's nothing to go back on the neutral because it's just creating a circle, or it's creating a circuit on line 1 and line 2.
Right.
But within the home, typically, yes, those neutrals are going to be hot so long as there's a circuit being created.
Yeah, and I think it's important to note that when you're sizing your neutral, in general, most of the time you're going to size it the same as your current carrying conductors because it is intended to carry current.
Yeah.
But there's a whole section in the NEC, I think it's like 260-ish, that talks about neutral sizing and when you can make it smaller. But from a SolarEdge perspective, if you're doing our commercial inverters, no longer Nexus, but if you're doing commercial inverters, our neutral is a non-current carrying conductor. And if you need to have the neutral, just references voltage is all it does, then you can size it the same size as your equipment grounding conductor. However, if you drop the neutral altogether, which you can do, because you can have a 208 no neutral, then you save your money on not having a neutral at all.
That does bring up a good point about commercial systems. One of the biggest problems that I ran into helping out folks that were doing commercial systems is check the data sheet to make sure that the inverter that you're working with supports either a delta or Y configuration. A lot of the Synergy inverters support delta, but a lot of the early ones only supported Y.
Yeah.
And if you did something like you were working on a 208 3-phase and you had a step-up transformer to go up to like a 480, the transformers are typically a lot more cheap if you don't have a neutral.
Yeah.
And so what a lot of installers were doing is they were installing the non-neutral step-up transformers, and they were having all kinds of issues with phase imbalance, or God help us, they were just bonding the neutral to ground.
Terrifying.
In a commercial system, because they're like, well, yeah, neutral's bonded to ground. It's the same. Doesn't work the same like that. So again, biggest takeaway if you were watching this today, grounding is awesome. Only bond your neutral and ground at your service entrance or
the place where your first disconnect occurs.
Exactly. And so thanks for each and every one of you for joining us today. I did want to give a quick tour. We have a new feature on Night Mode, and it's a little messy right now, but I'm going to show it anyway. So, if you look right here, we actually have a couch.
Hooray,
so,
couch!
Yay, we've got a guest couch. So, all of those lights and things on tripods are actually going to be mounted to the wall here in the very near future, and so is that SolarEdge logo. That SolarEdge logo is going to go right up here. And we'll get some LEDs on it to make it look pretty and do cool things. But yeah, really excited about having some guests join us here in the very near future. We've got folks that are going to be coming in from the commercial market, from the residential market, not just from SolarEdge, but also externally as well to come and talk, as well as having some guests online. So this new system that we've got and the new setup that we've got allows us to do a lot more cool things. So look for guests to be joining us here in the very near future.
Yeah, I'm excited about that.
Yeah.
Have some guests on the show, and instead of just listening to you and I talk.
I know, right?
You get to hear other people talk.
So you'll get to hear experts from different fields give you their take on how to be successful out there in the world. So
That's right.
Well, we've reached the end of another hour, and I had a great time today. I'm sorry that we couldn't be online.
We couldn't be live.
We couldn't be live. Network issues, but did enjoy chatting with a few of you that were able to stay on with us during chat and join us on our secondary link. Really appreciate your time, and welcome back. It's great to see you again. Until next time, stay sunny.
Stay optimized.